Retool is the fast way to build internal tools. As a team of developers, we realize that all internal tools are made of the same building blocks: tables, drop-downs, buttons, text inputs. Rather than building a tool from scratch and wasting hours searching for that perfect React component or wrangling data sources and APIs, Retool gives you a point, click, and drag and drop interface that makes it super simple to build internal UIs in hours, not days, all with the ability to dive in and customize every aspect with code. Companies like DoorDash, Brex, Plaid, and even Amazon use Retool to build their internal tools super fast. Give Retool a try now at retool.com. That's retool.com. Hey friends, I'm Scott Hanselman, and it's another episode of Hanselman Minutes. I'm here with Limor Fried. How are you?
Hello, I'm so glad. We were just having a good Kibitz Fest beforehand, but now we're officially on this podcast. Thank you for having me.
Yeah, thank you for being here. I'm realizing that I need to start pressing record earlier because, you said, we were kibitzing for 20 minutes. We're this should have been the show.
It should have been we've had a little freedom to talk the talk, but we're gonna rehash some of the things we discussed now that we're all comfortable.
Yes.
So we're here for a bit, and I'm Limor Fried. So hello everybody listening in or watching. And I'm actually, if you're watching the video, I'm at the AdaFruit factory. I'm actually going to do something really risky. I'm going to pick up the camera and pan it around. Is that cool?
Oh my goodness, let's do it. So that is risky.
So this is our happy Pride Month. So this is the machine line you can see over there. This is our manufacturing line where we actually do pick and placing of electronics. So all the computers and phones and devices that are on your desk that you love, all of those go through pick and place machines. We have circuit boards that place the components on them. And I designed those boards using software, and then it's actually manufactured here at our factory in Manhattan. This is my desk. I'm in the middle of the manufacturing floor, which is cool because my little eyeball tendrils can see everything from the testing zone to the kitting zone where we get the kits together to preparation to maintenance, et cetera, et cetera. And so this is my company, and this is where I live. This is my little bubble.
When I visited there, and I'll put a link in the show notes so people can look at that YouTube on the AdaFruit channel, which is one of the best YouTube channels.
Oh, yeah, we have tons of viewable videos. People want to watch machines, we got machines.
Yeah, so I went in there, and I was like, wait a second, I'm in Manhattan, and suddenly it just opened up into this giant, Costco, level, giant football field warehouse, and I just assumed that everything would be elsewhere, overseas somewhere. And it was surprising.
There is a lot of manufacturing overseas, right? Obviously a lot of it in China, but also, the Raspberry Pi is manufactured in the UK and Wales, which is super cool. We do have a lot of manufacturing in the US, but it's now much more focused towards military or small run or whenever people really need to worry about their intellectual property, they don't want it to leave the country. So we do manufacturing here. We're actually in a building. It's cool. This building historically was actually an inductor factory for Westinghouse. So this actually was first built in Victorian era. It was doing manufacturing, electronics manufacturing for the massive, and I mean massive, radio industry that was in Manhattan, right? It was headquartered here or something. Everyone loved radios because they're cool, but you have to make inductors and capacitors and switches and buttons, whatever. That was all manufactured, a lot of it here in Manhattan. This district, which I'm in now, which is Hudson Square, then became a printing district. So printing presses, because you need a very big floor plate that's also concrete, very strong, because the printing presses are so big and they vibrate when they go ka-chunk, 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 ka-chunk. And so there's still a bit of printing going on here, although a lot of the printing has moved to New Jersey or Brooklyn and Queens. This area is still a little bit industrial. It's one of the last zoned for light manufacturing areas in Manhattan. But even now, it recently got rezoned, so there's going to be more residential.
Mm-hmm. And I assume you have to have a cool relationship with the building owner and stuff, and they love having Adafruit in there causing trouble.
Yeah, well, they have a certificate. They have a certificate of occupancy, which is for light manufacturing. It kind of gives them a little bit of something about the occupancy is good if they can get light manufacturing in. They get to keep that certificate. I think it kind of keeps them from having to do some sort of inspections or something. I don't know. Mm-hmm. So they were kind of happy to see that we actually are doing light industrial manufacturing here.
Mhm.
which we do. You can even hear some of the machines. That's why like people are like, what's that noise? Why isn't it like deathly quiet? Because we're actually making stuff.
Yeah, it's so cool to see. Like you held up that plate there. That what is that
Right.
word
Yeah,
for that?
this is an ortho keypad. You can see it's got five rows by 6 columns, and then you can plug key switches into it. So
Hmm.
this is what it looks like. This is my prototype. So these
Oh
are
wow.
Cherry MX compatible switches. So like a lot of people have mechanical keyboards,
Okay.
but if you want to make your own keyboard, this is a grid that you can snap apart. So you can
Oh,
like
I was
snap it
wondering if I could
into,
snap it apart. So I could
yeah,
go and
it's
make little stream decks that are totally my own and totally
yes, that's the
I'm in
idea.
control.
Yes, that's the idea. So you can make custom control. So you can even sort of see behind it. You can see me because it's a
Yeah, yeah,
snap
yeah.
apart design.
Oh wow.
And so that's what we're working on today. We're doing diode matrix pull request fixes, testing to get this working. And then this is my prototype, which we hand make here. I hand pick and placed it.
Hmm.
But then when it's ready to go, the machine will do the work for me because I'm lazy and I want the machine to do it.
And pick and place is something picks up the component and then places it on the board and then
Yeah.
solders
So
it.
so components actually come on reels. I don't think I have like a reel or two here. They come on reels, like in this in a silver bag, and the components. It's a little bit like Pez, like the little parts like kind of pop off one at a
Hmm.
time. They're held
Yeah,
in a
yeah.
little plastic tape, and there's a machine that uses it has an XY gantry, and it has these little vacuum nozzles, and sort of like when you go to when you were a kid or maybe you're an adult, and you like put the straw in your milk, and then you put your finger on top and you lift it. It's that same concept but with yes, exactly, but with very, very small components. It picks them up and places them down on the circuit board with like extreme precision. But one of the things we like about this building, like I said, the floor is very thick. So as it moves around, it doesn't vibrate, which means it can maintain that precision. You can't, usually these are on the ground floor, but we're actually many floors up. And we can do that because the floor here is so thick because it's designed for industrial manufacturing.
That's such an interesting thing when I try to teach software, and I think you do the same when I watch you teaching electronics, is systems thinking. Let's just take a moment and like drink that in for a second. The
Mm.
construction of your building and the stability, the relative stability of the floor and the building and its sways could potentially affect within a millimeter, half a millimeter or
Yeah.
less
Oh, absolutely.
where a thing gets pressed on a board, and that matters to the customer at the end.
Yes, because it affects your yield. So a lot like when you do, I think a lot of people who watch your show probably compile code. I actually write a lot of code. Most of my stuff is in software and firmware. And there's errors and there's warnings, right? Your compiler or your whatever it is that your interpreter is going to tell you like you have an error in your code. But sometimes they'll tell you things that are like, well, this is not an error, but like I don't like it. Like with a C compiler,
Could
you
be a
turn on.
problem.
It could be a problem. Maybe you meant to do it, maybe you didn't. Or linting, right? So the machine would work fine. It wouldn't error, but all those warnings, all those things that could be a little bit wrong, they can stack up and cause failures in the end. Um, with manufacturing, you have this, you need to be 99.9% precise and accurate at each step because that multiplies out. And there's like 4 or 5 different steps in manufacturing. You have the precision of the circuit board design. And then there's the precision of the stencil printer, which is what puts the paste that gets melted onto the circuit board, which when you go through a later step, it melts down and it sort of sets the pieces in place. And then there's the precision of the pick and place, which picks up the component and places it. And then there's the accuracy of the oven, which has to evenly heat up the whole thing. If you don't have even heating, you get some parts that are hotter than others before, they get hot spots. The components actually start to lift and they warp. So all of these little things together, piece by piece, you need to have them all that precision adds up to whether you can manufacture something in the end where all the things that come out of the machine are good. Because if you have one bad part, it can destroy an entire product. Now, luckily, my parts are not super expensive, but if you have an $800 device or $500 computer and one thing doesn't work, and then it has to go into rework, it's a lot of effort, and you want to avoid that because that's hand labor. You want to have as much stuff manufactured because it's more fun to watch a machine do stuff than have to do it yourself.
It's amazing though when I hear stuff like that anything works at all, that we're even having this conversation. The stack is so deep.
Oh, no. So here's systems theory. It's all feedback systems. Okay. And I tell people this all the time. This is one of the most important things I learned in school was our bodies and the world in general is extremely when they say gross motion, not gross like icky, but gross as in it's very uncontrolled. Like you don't have a lot of control over, or the nature in general. Things happen very radically, right? It's like emotion and growth and activity. It's like very extreme. Like there's not a lot of precision in the output, but there's always these feedback cycles that let us regulate and improve the accuracy of systems and processes, which is like a lot of words. But let's put it this way: like if you're, I don't know if you do like model making, like some people like paint models. If you have a brush and you have your eyes closed, like people can train to be able to paint accurately with their eyes closed. But for the most part, if you try to draw with your eyes closed, you are going to have the basic shape, but it's kind of all over the place. Like the circles aren't round and like things that you thought touched were not, because you can't get that feedback from your vision system. When you open your eyes, you can then actually more accurately draw. You can actually have things touch and you can see where things are and you can place your motor reflexes in the right location. And if you're doing really precise art, like you're doing little miniature models, you want to have a magnifying glass, right? And the magnifying glass doesn't improve your muscle control. It improves your eyeball resolution. That feedback system gets better. So you're like, what does it have to do with electronics? All the machines that we have are like, they're totally like, there's just motors flying and who knows, and they get older and sometimes it's humid and sometimes it's hot and sometimes there's light, but the camera systems are really good. The vision system is really good. And because the vision is so good, it makes up for like everything else kind of sucking. Like the stencil printer makes mistakes all the time, but there's a vision check at the end and it does a vision inspection. It says like, oh, we forgot something here. And it'll like blink a light and it'll say, hey person, we have to have more paste, or you need to do a cleaning cycle, and it will actually kind of help you redo the work. So feedback systems, amazing.
It's interesting that computer vision, taking in this case, adding additional bodies. Like you could hire a human to stare at that thing, but they get tired and all that kind of stuff. Computer vision is making older devices more precise by allowing you to catch errors, as opposed to what I ignorantly would have done is like, well, I guess we'd have to buy a better, more precise device. But
you can do so much with a good feedback system. And this is like how the universe runs. Feedback systems is what lets us do things repeatedly, because you can't predict or control so much. Like there's this weird lie that when you're in school, you think everything's linear. You're like, I'm going to do like linear approximations. Okay, nothing is actually linear in real life except for like conceptual math. In reality, everything is so flexible and weird and affected by thousands of different variables that the only thing you can do is just have like really excellent feedback systems.
Which is like a metaphor for like life and taking feedback from family and friends.
For everything, including programming. If you have a tight feedback loop that gives you instant good feedback on your programming, right? Which is why I like Python, because it's really instant, gives you instant feedback. You can much more quickly get to the end goal, which is this program that you're trying to write. If whenever you're writing code, right? Because when you sit down, like there's this like game that I've heard, like people try to like code without a computer. They just like, somebody's like, okay, write the Fibonacci program, and they just like say out loud what the program is, right? Imagine if, like, yes, and people used to do that with machines. Like you'd have to punch cards, and you had no idea what was going on. You wouldn't find out till the next day. The feedback loop is so big, it takes so long that you can't have these quick iterative improvements. So shortening feedback loops is like, and improving the quality of the feedback is how we can do better with these imperfect, perfect bodies and imperfect, perfect brains. I love our brains and our bodies, but like, they kind of mess up a little bit sometimes.
I'm currently and have for the last year on and off on the weekends been trying to build Ben Eater's 6502
Mm.
system, from like 7400 series parts and breadboards and stuff like that. Somewhere in the middle, something's gone wrong, and it
Oh
works
yeah.
like 40% of the time.
Yeah.
Like literally, like on a random Tuesday, I can plug the thing in and it's amazing. And then another day, it's just like, didn't work.
Yeah.
And I feel like I've missed a feedback loop at some point because it's so gross. Like it could be, like you said, humidity. It could be a
Yeah,
wire's too
it could be a
thick.
wire's loose, and when it's cold, when it's hot, it's a cold solder joint, and just
Mm-hmm.
depending on whether it's flexed or not. Yeah,
Quantum effects.
electronics is a little annoying.
But to your point about Python, this is one of your Pi portals
Yes.
with my blood sugar on it.
Oh yeah.
That's my real-time blood sugar in
Yeah.
green and an arrow there, talking to the open source system that runs my diabetes.
Yeah.
And this runs Circuit Python, which I just plug this in and it shows up as a disk drive. I open it up in Visual Studio Code. I make the change. I hit save, and this thing starts. It just recompiles. It sees the
Yeah.
file system change. That inner loop, that developer's inner loop, the for loop that is my development process, allows us to
Yeah.
go and do things. I used to have to like pull the chip off the board, flash the firmware, put the chip back on the board.
Yeah.
Oh,
But let's talk about like the feedback loop that you're creating, right? Because you have a feedback loop that you're building for your body.
yeah, yeah.
Right. So like how would historically, how would you know your blood sugar? Like you'd probably have to do a blood, like, you'd prick your finger, you take the little strip and you'd like wait a couple
Yep.
minutes. And
So,
so
yeah,
you wouldn't know until you'd have to do it every few hours to know where you are.
that's a good point. The feedback loop for diabetics, for type 1 diabetics, is really challenging because when you're looking at your blood sugar with a finger stick, you're looking at the past.
Right.
So I'm asking now what my blood sugar is, and I'm seeing
Yeah.
15 minutes ago.
Yeah.
And then I take
It's like
insulin,
you
and
compiled your code and it's like you have to wait 15
yeah.
minutes
Well,
to
it's like
see what
looking at the
happened.
sun and you see the light from 8 minutes ago.
Yeah.
And then you say, all right, change my blood sugar, give me some insulin. That doesn't even do anything for an hour and a half. So you're
Right.
constantly living in this, like, I always imagine being on an airplane. I look at the
Yeah.
altimeter, it's a lie. I say, pull up, and nothing happens for an hour. And then that loop is trying to be
Bad feedback system. Not bad, but extremely delayed feedback system.
suboptimal.
But now you have, with all this technology you've got much faster feedback loops. So you think you do think it helps you regulate and kind of even out, or
I
does it
think that
not?
it does. I like to think about it as I'm driving a car. I'm in a 3-lane highway. I'm in the center lane. I can either weave back and forth by making big, gross movements,
Yeah.
or I can do that driving thing that we do where we just kind of
Yeah.
like shake on the thing. So I'm still moving, but I don't think I'm not oscillating between
Yeah.
highs and lows. It's less highs and less lows.
Feedback systems,
Feedback
aren't they great?
systems.
That should be like the motto of this show.
There you go. There's the name. The title of the show is Feedback Systems.
Feedback systems are very powerful. I think it's a shame people don't. It's often taught very late. If you're an engineer, it's taught very late in your career, which is, I think, unfortunate because it makes it harder to understand things. Huge. Even though I don't use feedback systems, I think about them. Do you know what I mean? Like, I think about what is the feedback loop here. Anyways, so we're talking about CircuitPython, which one of the goals was to remove the again 15-minute feedback loop of embedded engineering, which is, and when I started, it was even worse. You'd have to UV erase your chip. So you'd have to remove the chip, put it in the UV eraser, wait, 5 to 10 minutes until it was UV erased, and then you could use it. The chips look cool. They were golden because they had the UV EEPROM in them. But now, with flash microcontrollers and these very powerful microcontrollers, you can do stuff like run interpreted language. The problem is that the chips that we have now are so big that compiling for them, it's kind of like a deal. Like, it takes time. Like, it used to be pretty fast because they were small, but like as things got bigger and bigger, and I think developers see this too. Like, code that people write now have so many dependencies and like so much stuff that it's good because we are able to build such bigger, more advanced programs, but like there's a lot involved. It's not like little DOS programs anymore. It's like hundreds of thousands of lines of code could be involved.
Hey friends, I know that you like podcasts because you're listening to this one, so I'd like to introduce you to another, the Merge Conflict Podcast. It's a weekly discussion with developers Frank and James on all things development, technology, and more. After years of being friends, Frank and James finally decided to sit down and start a podcast about their lives as mobile developers using Xamarin. Much more than just another mobile development podcast, Merge Conflict reaches all areas of development, including desktop, server, and of course mobile. They also cover fun things happening in the world of technology and gaming and whatever else happens to be on their minds. Head to mergeconflict.fm to learn more or search for Merge Conflict in your favorite podcast app today to subscribe. Here's a question for you. So I was teaching some stuff to an intern, and I'm old man who shakes fist at cloud, and they're fresh and new.
Yeah.
And I realized, and actually Maria Nagaga on my team said that, Scott, you're teaching from the metal up. Like, let's talk about memory. Let's talk about CPU. Let's talk about assembly language. And I go up from silicon up.
Yeah.
But the new people think about Chrome, the glass on the monitor, and they go from the glass back down into the computer. So they're thinking about the user surface, mice, keyboard, screen, and they're trying to tunnel into the mountain this way, and I'm trying to build up from the bottom. And they said, this is their proposal, you, Scott, your way of teaching is like, hey, you want to drive a car? Let's talk about internal combustion.
Yeah.
Maybe not the way to do things.
I will agree with your intern that when I teach from the top down.
Okay.
Because it frustrates me that a lot of electronics, the way it's historically been taught, and there's nothing wrong with it, but I personally didn't like it, was here's an electron. It's like you never actually have to deal with an electron at any point in doing electronics until you get to something that is not working because of some model that you don't understand. But in general, you're not really dealing with that stuff.
Yeah.
And I think the same thing for developers. So like somebody who's learning to program now does not know the difference between cache memory, RAM memory, disk network. They don't, and they shouldn't. Yes, it'll affect the speed at which things run, but as us old people shaking our fists in the clouds have learned, the root of all evil is premature optimization. So maybe they're right. Maybe get your, what people say, the minimum viable product, get that going. And yes, it will not be very fast because they're not using the optimization systems that they should to get the performance that you eventually do need to add.
Yeah.
But they just don't understand. Knowing that may not be necessary. Another thing I've noticed is like engineers often have, because they have so much knowledge of what is the right way to do something and what is the correct abstraction, is that they get engineers paralysis where they can't make forward motion because they're just like, okay, I do it this way, but the real way to do it is that way. But then like now I have to like it, they
That's my life.
Just, there's actually too much going on. And one of the things that I have to do when I'm managing folks like that is like try to break it down and just say like, you have to do this one piece in one step. And they're like, that's not the right way to do it. And I'm like, look, all code gets refactored. So let's just get something working because we don't know what we don't know about this system yet. Like you think, like you think, oh, my bottleneck is going to be this, but it could be something different. And like, you also don't like, sometimes you're like, you're programming something and you don't realize that that data isn't accessible to you, or like, like this kernel does it one way, but the other kernels do it another way. And you're not going to be able to depend on it anyhow. So like, sometimes you have to make the wrong decisions to get the right outcome. So like the file system on CircuitPython, for example, like you said, you plug it in, it shows the disk drive, right? So it's a FAT file system. It's actually like FAT 12 or FAT 16 or something, right? And that's like the wrong thing to do, right? If you ask any engineer, what is the correct file system to put on a flash memory that does not have wear leveling? They'll say, oh, you should absolutely use LittleFS or some journaling file system because, if you're running FAT, your first sector is going to be overwritten every single time and you're going to like burn out the memory, right? Because that's all they've learned is like, is this is the correct, technically correct thing. And my answer is like, yeah, but like, it's going to be a really long time until that happens. And so we're going to make the decision to do something that is more user friendly, which is have a fat exposed file system, even though technically that is totally the incorrect answer. That it is not the proper file system to use on a flash memory system. And we can always refactor it later when we feel like it, but not today.
But that's what makes this magical, right? Like, I don't need any drivers. I don't need to go and worry that my version of Windows or my version of Mac or whatever is not going to work. Like, it just works.
Mass storage is the one thing that every computer has a built-in driver for. Believe me, even HID, you can't depend or trust it. USB CDC also doesn't always, but mass storage, everything knows about mass storage. Everything.
Mm-hmm.
It is the universal way of interacting with computers, and so why I'm like really into mass storage as a method of programming. And actually, I'm going to give a mega shout out to the folks at Microsoft Research who designed UF2, which is the bootloader system that we use with CircuitPython, which shows up as a mass storage drive and you drag over a hex file. They actually figured out how to do it. And what's, this is like, again, this is the technical thing that I thought was really brilliant is people have done programming chips via mass storage where you drag a file over. This is not new. This has happened before. However, every operating system handles, even though they know about mass storage, they write things out of order because there's like caching that's happening underneath. So it's like they try to be smart. So like Linux always starts at the beginning and writes the full file. And like Mac, it's like they always have these dot files that .7fs, whatever, that they write at the same time. And then like Microsoft does it with like sector change or whatever. Everyone's trying to do their own implementation. And that actually would really mess up bootloaders because they couldn't cope with the fact that all the files would come in out of order. It didn't start at byte 0 and write. That's not how files are written on a mass storage file system. It's actually written out of order. And they came up with, again, they were like, well, what if we just make everything twice as big and then we pad it out so it doesn't matter what order it's written in. And again, this is like, it's a great engineering decision that is wrong. Right?
Right. It's inefficient. There's all kinds of reasons we could throw pebbles at it and say that was dumb.
It's inefficient, but they're like, who cares?
Mm-hmm.
Right? Like, it's fine. Memory is infinite. Just use it.
That's a t-shirt now.
Yes.
Memory is
memory is basic on a computer. Memory is basically infinite.
Like, tell that to the people who run like Slack and Chrome.
Well, but you know what? It
kind of is still.
It kind of is, right? I mean, like, what's the point of having these computers? I mean, like, Dropbox was written in Python. You know what I mean? Like, it matters, but maybe it doesn't matter.
So trying to apply some of these lessons to life, it makes me think about what I'm trying to tell my 15-year-old who has no interest in computers and wants to be a scriptwriter for TV. And he gets analysis paralysis, like you've described, where he will talk about a script for months.
But not actually write it.
Freaking write it down. And I said, dude, because that's how I talk to my 15-year-old, just slap the keyboard. Just start slapping the keyboard. Well, but he's coming up with all these different reasons. It's like, I want him to get into the feedback loop. Write a first draft.
He's got fear. He's got fear right now.
Yeah. He wants to write the final on one try.
Yeah. He's scared of what if it doesn't come out right.
Yeah.
And that fear is the biggest, and that's what engineering paralysis is. The same thing. It's like the fear of doing something and you didn't do a good job the first time, because there's this myth of, the first time you do something, it's going to be perfect. And I don't know the answer for this.
Well, we perpetuate that myth when we talk about 10x programmers and people who imply that, like, oh, the demo worked on the first try. That's one of the reasons when I do demos and stuff, I make them not work.
Yeah.
Because watching someone that you will follow on the internet stick the landing every time, that's no fun. I want to see the feedback loop.
Yeah, it's interesting. I mean, like, one of the cool things about GitHub is you can see every commit. You can see every issue and they were closed. So you can, you do have access to that. You don't just see the final software at the end, but the whole process that went through it, which is like totally gnarly.
It's cool to watch you all go through your process on your YouTube and now on your TikTok, which I'm a big fan of, as you make things better, and then you have your team members make content and they go and build stuff, and they do crazy, wacky, creative stuff. We bought your Ada boxes, and you had these wonderful googly eyes with screens on them. This is the best thing ever, by the way. This is a joy. I'm just going to like have a free advertisement for Ada boxes.
Okay, good, because we have some slots left over, but it is a huge lift that we do every year.
Is it really? Okay,
Yeah,
so these are this is like the Columbia Record Club, but electronics. Surprise boxes that show up every couple of months with stuff in them. You never know what you're going to get. You open the box up. I've got like literally stacks of these things. They're actually becoming a problem. I have to have a whole separate room in the house for these.
And they're only quarterly.
They're only quarterly? I must have been there since box 2 because I have like 15 of these things.
And you've seen the evolution, right? It started with like, feather boards, and you wrote stuff in Arduino, and then we had CircuitPython. And one of the things so the Ada boxes have turned into a way of bookmarking, earmarking, like we put a pin in a development that we want to achieve by the end of that quarter.
Mm-hmm.
So one of my favorite descriptions of development and output is from Square Enix, who makes the Final Fantasy games.
Mm-hmm.
And like one of the people that, I'm assuming it's from them because I associate, but somebody said like, what's a Final Fantasy game? And they answered, a Final Fantasy game is the best game we can make with the technology available at publish time. Right? Which is like not what you would say. You'd think like, it's a Japanese RPG. So, what I'm trying to do is like, what is the technology that's available, and what is the newest technology, and what can I make with that newest technology to kind of introduce it and sort of force our hand to actually do a good support development system for it. So like, there's this new chip from Espressif that does Wi-Fi at low cost. The last few boxes have been using that chip, and we've gotten better and better and better. Like we really wanted low power. So it's like we did an e-ink project with Wi-Fi because we're like, how can we force ourselves to finish this low power code? And it's like, well, we have a deadline with that we're going to ship this box that has e-ink, and it has to be low power, and it sits on your fridge, and it's
on my fridge right now. It's on my fridge.
It's very handy.
It's got our to-do list.
We have like a dozen different projects. I have one that has like the weather thing and like the number of vaccinations in the U.S., like how far we've gotten along. So it's that's how I force the development and the release, right? Because with your kiddo, how do you get them into a development and release cycle when they haven't been able to do that yet? And sometimes having event deadlines is good. Like, do you want to submit the script to this art fellowship or grant or whatever? Sometimes that's needed. It's one of the things about people that's very tough, because it in of itself, you can't force the feedback loop for the feedback loop. It's like, how do you get somebody into a healthy feedback loop that isn't based on fear and like really bad self-esteem? Right? How do you make it healthy? That I don't know.
Yeah. And that has been the challenge of parenting for the last 15 years is you can do anything, set your mind to it, and all the kind of typical parenting type things. But it's like, just slap the keyboard. We'll do draft 1. We'll do draft 99. But his ideas are so great. I always feel like that about these. Like I take my Ada boxes and I turn them into something, and then I get it to 80%. And then that's where my paralysis happens. And then the analysis, I can get it crappy, but I can't spike the ball at the end zone and like do the last.
Yeah. And I think that's actually what management is supposed to be, right? Like that's how, because like I run this company and I try to get things to the end. It's the finishing, right? This is the hardest thing, is to get it to the finish. And I kind of like, my job is to like get people across the line to the finish, because everyone loves to start the project, but I have to get them to finish it to the point where we can publish it. And I don't know any other way of doing it than having like these deadlines or events, or just saying, hey, this is what I need. Sometimes you can like sweeten the deal. It's like, okay, after you finish this thing I need, you can do something you want, but you also have to finish it. But definitely if you have a gaggle of people without something to kind of, without that publication push, it's going to be very hard for people to iterate, because right now your kid isn't in the iteration cycle yet. He's swimming at the beginning. He needs to compile the code and see the output, even if it's a warning and full of errors. If you don't write that first few lines of code because you're so scared of the
You've given me an
error.
idea.
Yeah.
I'm going to tell him if he gives me 30 pages, then I'll print it and bind it. Then he can hold it, and then he can do another one. That will give him an arbitrary thing.
Yeah, I don't know. I mean, is there anything he wants to screenwrite for television?
Oh yeah, he just sits there and he talks about, like, I don't like the way that the motivation of this character in this show. I think they should have done it like this. He's got amazing ideas, but he just it's a lot of talk. But then when he sits in front of Google Docs, he just paralyzed.
Yeah. I wonder if it would be good for him to do like a voice.
Yeah, yeah, that's a good point. Actually, that's a great idea. We could do a transcription thing. Tell the story and then take the voice note and do it. See, this is great. So what you're doing is you're managing me, and you're encouraging me to think about feedback loops.
Well, I'm trying to think about how you do it. One thing that, because I do a lot of writing, is, first off, I acknowledge that it's not going to be done. I do some of the tricks, like you start with the second paragraph. You don't start with the first paragraph is the hardest to write.
Ooh.
So you start with the second paragraph.
Just skip right over the first paragraph.
Just skip over the first. Yeah, just skip over the beginning and go right to the middle. Go right to the exciting part, the meat of it, and then you go at the end. And then it's easy, because then you just have to
you do your bookends later.
Yeah, I remember I think Boing Boing used to the zine, not the I think it was Boing Boing. They said it was Cool Tools. They said, I think, and they were like, if you're going to write a review of a tool, write the review and then send us an email telling us why we should print your review, and then delete the review and we'll publish the email. Do you know what I mean? Like,
it's true though.
The review is stilted.
Yeah.
It's like, how do you capture the energetic review, the thing that's true, not the thing that you think people want to read. Very hard. This is, I think what gets art elevated. It's like you have to push through the discomfort of being human into the truth of how you see something. Like, I don't know how to raise your kid, though. This is totally your problem.
No, I know. I'm on my that was the whole totally the whole thing was to sneak you into a podcast and then get parenting advice, which I think was
I don't know. It's tough. I don't know.
Humans are squishy. Humans
are very squishy.
Yes, it's feedback systems.
But you have to figure out what is it that they want, what is it that they're afraid of, what makes them happy. And then it's easier for me because the people who I'm telling to do that, I pay them. And so that there is this, there's this carrot and stick.
Nice. Yeah.
It's like, if you don't do it, I can't keep paying you. So but you don't do that with your kid. Yeah. I'm always weirded. I mean, I know people are like, oh, I pay my kid to do their homework. And I'm just always like, that's kind of weird.
No.
But the people who do it, right?
I guess.
It's the only thing that works.
I pay him in Ada boxes right now. So.
Yeah, that's good. I don't know. I'll think about how do you motivate someone to write? I mean, obviously this is one of humanity's greatest challenges.
It's the thing, right? It's I'm inspired. I want to do so many things, but then I'll do nothing, and it's okay though. Sometimes we just need to find our tribe, find our people, and sit around and brainstorm together.
Well, how do you do it? What makes you?
That is
why do you record a podcast every week? It is a problem. Okay.
It's a problem because I'm vibrating with enthusiasm about the universe around me.
Yeah.
I tell this story about how when my wife's family came over from South Africa and they were sitting and they were all jet lagged and the kids were like, why is it light here? It should be dark. I feel weird. And I was like, oh, and I grab an orange. I'm like, okay, you hold this. You're the sun. And then I start building a model of the solar system in fruit. And they're just like, just stop. Just leave us alone. But how can you not be excited? So I just have that inner thing and I don't know where it's from and I can't give that to somebody for free. It's just everyone's wired differently.
Yeah.
I mean, you kind of made this in your dorm room and now you have a company and you're revolutionizing electronics for the world and people of all ages are building stuff. You were obviously vibrating with the enthusiasm to do that 20 years ago.
Yeah, but I'm like I'm really motivated by hate. Like it's not very healthy and like very
Hate of what? The just lousy electronic companies?
Yeah, I just really hate bad things. And I get so angry, and like Phil does this to me on purpose. Like he purposefully like sends me. You know, the people like smell this milk. It's terrible. He like sends me really bad engineering, and then he's just like, "Look at this," and I'm like, "That's so bad," and I'm like, "I hate it," and he's
And now
like,
you have to
"Yeah,"
fix it.
and I'm like, "Fuck, I have to fix it." And then I'm like, "I have to." I'm so angry that I have to. I stay up late, and I'm in the morning. I'm like, "Okay, I designed a better thing." Then so they did it wrong, right? I'm trying to channel that like nerd judgmentalism.
Yeah, spite-driven development.
Very spite, like hate forking.
Hate forking.
Love it. You never heard of hate forking?
Yeah, I love that.
I mean, like that's half of like how things are done, and I think people don't admit that as much. I think there is this like love and creativity and sharing. It's like yeah, but there's also like the other side of the coin, which is that there's something that you hate. Oh, for me.
But see, you just brought up a great point, and I'm going to actually end on this because I just told you at the beginning that my son really hates this show. Well, then you should write fanfic. You should do it differently.
Should write fanfic.
Should make it better.
He should be like the #1 fanfic writer.
Yeah.
I mean,
it is hate-driven development.
Maybe don't just be aware of what fanfic sites he's on. But like,
no, I understood. Yeah, I'm on them. Right. Like we're thinking about the Miss Marvel, Kamala Khan positive fanfic kind of like.
Yeah, no, it's okay, good. Just watch out for those Google searches, and if there's something that he hates, that hate is a very, very powerful motivator. I mean, like not hate like it's a true hate, but just like
I don't like that. I can make it better.
You don't like something, you can make it better, and I think that that some engineers say it's like, oh, build an XYZ that doesn't suck, right? Everyone has the frustration of dealing with or interacting with technology, and they're like, why is this so bad? And why can't it be better? And then now you actually have the ability to maybe make it better.
Very cool.
Hate-driven feedback loops.
Thank you for our outro music. That's the new outro music.
I'm going to stick to the engineering, no singing.
I appreciate you spending time with me today.
All right. Well, this was fun, and sorry to everybody who had to listen to us.
I think that for the 3 people that watched this all the way to the end, I appreciate them all. Love and everything. And say hi to Philip for me, please.
Easy. Hi, Phil. He says hi.
Okay. Hi, Phil. Is he gonna stick his head in?
You want us to come wave?
You're pretty awesome too, Phil. Thank you. All right. This has been another episode of Hansel Minutes, and we'll see you again next week.